In this demo, you will see how an EventStoreDB cluster can be provisioned in Azure Cloud. Before creating a cluster, we need to have a network. So we go to Project Networks on the console and then click New Network. Here, we fill out the network name, choose Azure as a provider, and then select the region. For this demo, we will use the West Europe region. Then we need to specify the CIDR block, the subnet IP, and the mask. Make sure that the IP range doesn't intersect with your own Azure VNet IP range. When all the details are provided, we can click the Create Network button. Now the network is being provisioned. The provisioning might take a while. You would need to refresh the status manually by clicking the rotating arrow button to see the actual status. When the network becomes active, we can create the EventStoreDB cluster. To do that, click on the Clusters item in the left navigation menu. There, click on the Create Cluster button. We need to specify the cluster name, choose Azure Provider and the server version. We also need to choose either we run the projection subsystem on the new cluster and which projections will be enabled. We can choose between disabling the projection subsystem entirely to increase performance of the cluster, run system projections only, or run both system and user projections. Please bear in mind that enabling projection subsystem and running projections decrease the cluster performance. Please refer to our documentation to know more about it. Follow by selecting the deployment topology and the instance size. The F1 instance size is only suitable for development and testing purposes. All other instance sizes can be used for production purposes. Please choose your instance size according to the projected volumes. All cluster nodes will have the same size. Then specify the disk size. Each node will get a disk of the specified size. Check the Microsoft documentation about IOPS limit applied to different premium SSD sizes. A smaller disk could cause lower cluster performance even for larger instances. Finally, we need to select the network which we created previously. I will also change the disk size to 64 GB. Now, as we have all the details, we can create a cluster. Provisioning a cluster in Azure might take a while. Meanwhile, we can check the cluster details in the bottom panel. Here we can see the cluster ID and provisioning status, cloud provider and the cluster topology, the product version, and connection details for different clients. I can always click on the refresh button to check the provisioning status. We can now leave the cluster page as it is still being provisioned and start connecting virtual networks together. So I will switch to the peering page and click the new peering button. We need to give peering a name and choose the EventStore Cloud Network which we created previously. Next, we need to provide the details about the VNet which we are going to peer with. First, we need the tenant ID. As I need to use Azure CLI for the next step, I have to log in with the CLI first. I log into my own Azure account. The CLI response already contains the tenant ID which I can use. You can also find the tenant ID in the Azure Active Directory UI. It is shown in the tenant information panel. If you have logged into Azure CLI previously, you can find the tenant ID by using the az-account command. We fill out the tenant ID with information retrieved from the Azure CLI or Azure AD. Then we need the resource ID of the target VNet. I visit the Azure portal for my own Azure account and open the VNet, which I plan to peer with EventStore Cloud. The resource ID for the VNet can be found on the Properties page. I can then copy the resource ID to the Peer Network ID field in the EventStore Cloud console. Finally, I need the target VNet address space, which I can find on the overview page of the VNet in Azure portal. Now I can paste the value to the peer address space field and click the Next button. Peering with Azure requires creating a service principal for EventStore Cloud on your Azure account. This page provides all the necessary information to do that. The first command creates the service principal itself. I paste the command to the terminal window and run it. The command executed successfully, so I can move to the next step. Now I need to give the new service principal some permissions to create the peering. To do so, I need a role definition JSON file. I can either download it or copy-paste the content. So I download the JSON role definition file to my home directory on the local machine. As my terminal is set to the home directory already, I can copy-paste the next command and execute it. Next, I need to assign a new role definition to the previously created service principal. I do that by executing the last command provided on the page. When all these steps are completed, I can finally click on the Create Peering button. The provisioning process again might take a few minutes. As the peering is being provisioned, I can refresh the page from time to time to update the status. Meanwhile, I can check if my cluster is ready by now. I can see that the cluster is now available. However, I cannot reach the cluster until the VNets are connected together by the new peering. This URL will allow me to open the EventStoreDB UI later on. We can see that the URL is composed by combining the cluster ID and the EventStore Cloud domain name. I can check the DNS record for the cluster domain name. Now I can see that it resolves to 3 IP addresses as expected. I can check if host names of individual nodes have IP addresses which are resolved previously. First node resolves as expected, so I try one more. Now let's check the peering provisioning status. The peering is now active. Let's see how it looks in Azure Portal. On the VNet page, I select Peerings. And there I see the new peering and also that it has the status Connected. EventStore Cloud clusters are not exposed to public internet, so I will use a VM, which is connected to the VNet that we have just peered with EventStore Cloud. It is a Windows VM with a public IP, so I can connect to it by RDP. I will copy the EventStoreDB UI URL and use it in the Azure VM. Here I paste the URL and get the usual login screen of EventStoreDB. Here I enter the admin changed default credentials, and I can see the old good green UI. Here I can click on the cluster status and confirm that it has 3 nodes as expected and all the nodes are online. I can also connect to another node by clicking the Show Website button in the nodes list. Here I need to log in again using the same credentials. Now I can click around in the UI to confirm that all options are available. It's always a good idea to change the default password even though the cluster cannot be accessed from the outside. So I click Users, choose the admin user and click Password Reset. Now I have to log in again using the new password. So now everything looks just fine. So let's check out how we can connect to the cluster using an SDK. I visit the documentation website and click on the gRPC clients button. Here I can get the connection string for the cloud cluster by using the cluster ID. So I go back to the cloud console and copy the cluster ID. Then I paste it on the documentation page and click on Fetch Configuration button. I can see that the cluster topology is correctly detected and I get the connection string generated. I can click on Connecting to Server, which brings me to the next page. The page already contains pre-generated code, which I can use for connecting to the cloud cluster. All the examples are provided in a couple of languages already, and more examples will be coming later. That's the end of this demo. I hope that you got an idea how to provision an EventStoreDB cluster in Azure.